So first I want to talk about epistemologies. So what are epistemologies? They are ways that we establish knowledge about the nature of truth and reality. So there is generally four primary epistemologies. Number one is faith, two is common sense, three is logic, and four is the scientific method. That's the one I have to pump up. So talk about faith. Faith is beliefs based on authority. So when we believe something is true because some expert says it's true, we are using faith as an epistemology. And we all do this, right? So our doctor tells us something, we're not all doctors, or an engineer tells us something. But when we believe them, we are using faith as an epistemology and believing what they say based on their authority. So there's personal testimonies of folks. So doctors, judges, politicians, scientists, and parents. So what's the problem with faith? Well, we all use faith. I'm not getting down on faith, but it can be wrong. So phrenology, for example, was a belief based on faith. So that's where they used to, way back in the day, they thought you could tell someone's personality based on the bumps on their head. It's obviously not true. And so an example where faith was wrong. Even more shocking, our doctors used to let blood out of people to make them better. And that was called bloodletting. Obviously wrong. TV infomercials, late night infomercials, where they're like, this product really works. If you buy that product, you are buying that product based on faith or someone's personal testimony. And even me. So I'm an expert, I'm an authority in the things we're learning in this class. And so guess what? I could be wrong. Just ask my wife. So science, however, uses observable evidence, not the testimony of authorities, in order to establish truth. So it is a more ideal epistemology for what we do. So then there's common sense. So common sense is when we believe a thing is true based on experience or our sensory observations. So something is true because our past experience tells us this is something that's true. So will the sun rise tomorrow? I believe so. I believe the sun's going to rise tomorrow because every day of my life, the sun has risen the next morning. So we believe that something is reasonable or not based on our past experiences and observations. When we do that, we're using common sense. Not so shockingly, our common sense can and has been wrong. So for example, early astronomers saw the sun go east to west, so they rightfully concluded, like I probably would have because this is not my field, right, that yeah, the sun revolves around the earth because that's what it looks like, just like the moon, right? Early folks also thought that flies came from rotten meat until someone had enough sense to put a basket over it and noticed it never developed flies. So that's not where flies come from. They're actually laying eggs. Optical illusions are another example where our sensory observations take a bad turn on us and can fool us. And superstition. So like why do basketball players, touch their socks and put their hand to the sky and whatnot before they shoot their free throws? Well, because superstitions in the past, they're making connections that may or may not be true, but that they think help them. So in science, the epistemology du jour, we use controlled empirical tests to see if there's a common cause of our observations. So we test the observations' reliability themselves. So then we have logic. So logic is a formal set of rules that lead to a conclusion that must be true if the premises are true. So the classic Socrates or Socrates, if you're from the 80s, something is true because it follows from a series of true premises. So all dogs have hair. Dagny is a dog. Hence, or therefore, Dagny has hair. That's a logical stream. So the social biologists, for example, assume that the entire goal of everything we do is to breed. Hence, when they interpret human behavior, all behaviors are interpreted logically to serve this end. So it can be wrong Not so shockingly, they even have a term for this one. It's called logical fallacies. So nothing is better than eternal happiness. Eating a hamburger is better than nothing. Therefore, eating a hamburger is better than eternal happiness. So obviously, stupid. Why? What's the fallacy here? The fallacy is a double meaning of the word nothing, right? No thing. So the post hoc ergo propter hoc is another fallacy. So this is the after the fact, therefore because of the fact, right? In Latin. So persons with college degrees earn more money on average. So we should just provide free degrees to everyone and everyone's going to be rich, right? That's sort of the logic. That's kind of fallacy you can run into with logic as an epistemology. Whereas in science, the premises of the logical beliefs themselves are tested empirically. Empirically just meaning we physically collect information on it to test those premises themselves. We just don't assume premises is true. So here's the one that I got to pump up this lecture, the scientific method. So the scientific method is, psychology is a science, and the scientific method is the method we use to establish truth in psychology. It is a method of empirical, analytical, and self-critical techniques for establishing truth. There are 8 special properties of the scientific method. So it's empirical. Empirical means, again, it's based on collected data, measurements, and observations. It's analytical. So we study very complex things in psychology. And so when we say that the scientific method is analytical, we're saying that it takes these complex things and breaks them down into their smaller components. So for example, you're going to learn to hate the DMV even more after this class because I worked there for a while, and so there's a lot of examples. We studied safe driving at DMV. I wasn't behind the counter. I was a researcher there. And how did we define something like safe driving? Well, we broke it down into its smaller components. We said, well, it's knowledge, skills, and abilities, or KSAs. So what knowledge do you need? There's the written test, for example. You need the information that is in the California Driver Handbook. There's skills. You actually have to be able to see and park, and abilities for you to be able to have the functionality to do those things. So self-critical and public, we do publish things and look for flaws in our own studies. That's part of what we do. We use our peer-reviewed research in order to criticize our own work. So trust me, mine gets criticized all the time. It's replicable. So this is probably one of the most important things on here. Scientific things, or things that are subject to the scientific method, have to be replicable. So that just means a fancy word for repeated. So if other people can't independently replicate or repeat your results, then we assume it wasn't a real finding. That's what we do. So no single study establishes facts. The truth, as close as we get to it in the scientific method, is established by the consensual validation of peers. That is, repeating the studies under different conditions and showing the same things. So keeping going with the scientific method and its 8 magical properties, we have that it's generalizable. So generalizability, again, is just a fancy term that means it's repeatable, but it's repeatable not exactly the same as the exact same people and exact same methods. You can actually broadly repeat it. If you change things, you can do it with other groups of people, slight variations in method. Findings that generalize, that are repeatable under different circumstances, it kind of seems like you're getting closer to something that's real, something that's true. So we want to be able to apply our findings to new samples and modify procedures. So 10-cent word of the day is parsimonious. Parsimonious, it's kind of funny. This complex looking word just means simple, right? So parsimonious is just another word for simple. And indeed, in science, the best answer to things is the one that is as simple as possible, but as Einstein said, but not more simple. So falsifiable, a very important characteristic of the scientific method. You have to be able to test things for it to be something subject to the epistemology of science. So specifically, not only test it, but you have to be able to test it and show that it's wrong. There has to be ways to prove that it's wrong. So science, we never actually prove anything is correct. We sort of like, here's where we're at today with science. So we tentatively support things, or we say, no, that's false. You can prove things false, but we never actually know truth. So all crows are black cannot be proven, right? Can you get every crow in the universe right now and, see that they're all black? You cannot. But you can falsify such a statement. What would you have to do to falsify that statement? You just got to find one crow that's not black. And, I bet there's an albino one out there somewhere. And finally, it is dynamic and self-correcting / tentative, too many words in there. But basically, it's not static. So when new findings arise that are counter to our understanding of truth, we change it, right? So we actually update things and change what we consider truth when new findings pop up. And that's the fancy word for that is dynamic. So we examine hypotheses, we give alternative explanations, and further studies are conducted to test those alternative or updated explanations. So, a lot of topics this week. It really is just sort of like a hodgepodge of different things that I have to introduce you to. And so, switching topics now for something totally different. Let's talk about 4 purposes and types of research. So this is going to shock you. There's exploratory research, and exploratory research does literally what it says it does. It's to develop new knowledge in an area. So you're exploring things. When you're exploring things, we call that exploratory research. So we use it frequently, or we call it that frequently, when there's a new area. We don't know much what's going on. We're just sort of, looking around, trying to figure out what's going on. And we want to develop theories that we maybe will test later. So another DMV example. So when I worked at DMV, we were in charge of the written test for California. And the test rates were almost twice as high for folks who took it in Spanish versus those who took it in English. And we didn't know why. So there's lots of potential theories on why that might have been the case. And so instead of just guessing like you would with logic, we actually went out and interviewed folks at DMV offices who took the test in Spanish in Central California, and we tried to understand why it was harder in Spanish than in English. Like, what's going on? That is it the translation? Is there words we're not using? Is it really sort of a reading issue? Like, what's going on here? Did you read the manual? There's another one. So we actually went out and tested it, and that was exploratory. So another one where the name says it all, there's descriptive research. You're never going to guess what descriptive research does. It describes things, specifically groups or situations or some phenomena or phenomenon of interest. So you describe what you're observing, and you discover, for example, about concert attendees. If you were doing that, it's kind of like reporting. You would be doing descriptive research, and it's actually not cheesy. I've done these sorts of studies as well. You're just sort of describing a situation or a group. So correlational research is huge, particularly in psychology, and it is when you look at whether naturally occurring phenomena or variables are related. And by naturally occurring, I don't mean nature. I mean, like, the researcher didn't manipulate it or cause the thing to happen. It just happened. You're just looking at a relationship between two things that are sort of already existing. So you cannot infer causation in correlational studies, which is like the famous sort of thing that all stat professors repeat over and over. So for example, we know that the number of toasters that a person has and their income level is strongly positively correlated. That is, people who own more toasters tend to make more money. So you would not then conclude, because this is a correlational relationship, and by the way, that's a true relationship, well, we should just start giving people toasters and then everyone's going to be rich. Ice cream sales and crime rates, yes, they are positively correlated, meaning when ice cream sales tend to be low, crime rates tend to be low. When ice cream sales tend to be high, crime rates tend to be high. That is a true relationship. It is not causal, meaning there's one doesn't cause the other. The reason that those two things sort of move up and down together is that there's a third variable they're both related to, and that's temperature. When it's warm or hot, people buy ice cream more, and when it's warm or hot, it's summer, and that's when crime rates tend to be higher. It has nothing to do with ice cream sales. So, all right, moving on. We've got our final one, again, with a name that literally means exactly what it does. Explanatory research explains things. That's what it does. So these should be easy to remember, at least I hope they are. When you're trying to explain phenomena or behaviors you're doing, explanatory research, so experimental studies, for example, tend to be explanatory research. So there's basic research, sort of a subcategory of explanatory research. And basic research is kind of the research I hate. It's the research that's sort of like testing or evaluating or developing theories on things as opposed to, actually trying to solve problems. It's sort of the lab thing or the computer modeling of things, that sort of thing is called what we call basic research. So you might have, for road rage as an example, you want to test a theory that it's caused by frustration and lack of control. You're looking at the underlying causes of road rage to test this sort of theory. So the sort of research I do is more applied, and I'm guessing that's what most of you will do, where we're doing research not just to test some theory or evaluate some hypothesis. What we really want to do is solve a problem. We want to meet some sort of practical need, and the word for that is applied research. Taking research and applying it to the real world, hence the name. So what increases recycling? So when I originally, for example, they started recycling in California, they used to put these bins out front of your house that you had to wash everything. You had to take the label off things. You couldn't have the lid on jars. It was a real pain in the butt. And then you put this sort of jar out there, or excuse me, you put this plastic bin out on the road, and if you didn't have your label off, they wouldn't take it. And guess what? People were like, this is too much of a pain in the butt. So everything became non-recycling and just went in their trash can. So what they figured out is, what if we just make a huge bin, and usually they're blue, right? And they can just throw whatever they want in there, and then we'll just hire people who work at the dump, who will actually do the cleaning and do the taking off of labels, etc. And so, boom, recycling went through the roof. So they were trying to solve this problem, and someone actually solved it, and I appreciate it too, because I recycle now as well. So one subtype of applied research is what we call human factors research. And the goal of human factors research specifically is to try to optimize the interactions of humans and technology in a particular environment. So that's called human factors research. So, for example, originally when cell phones came out, they did not have speakers on them, and they didn't have Bluetooth and that sort of thing, and folks were distracted on their cell phones in their cars. So someone figured out, hey, why don't we run it through the car stereo? And that was a way that they improved the interaction of humans and cell phones in cars. So the other big type of applied research, and this we actually don't talk about this to the very last week of class, is evaluation research. So evaluation research, I'm guessing, is what a lot of you will be doing in the future. And the goal of evaluation research is to determine if a program works, if it was implemented how it was supposed to be, what are the needs. So needs assessments fall under there. So this is where I have a lot of my research experience as well. So, for example, can companies provide commercial licensed drive tests instead of DMV? This was something we evaluated. So it turns out UPS, FedEx, other big companies, in order to get enough drivers, we actually, when I worked at DMV, farmed out the drive test to them. And indeed, they were able to show that we trained them, and they were able to show that folks who were trained by the companies tended to meet the same standards as if they had been licensed and tested by DMV. We tried to do that same thing with teenagers. So we did a pilot program where driving schools were allowed to give the drive test in lieu of DMV, and then we randomly resampled and retested some of them, and found that there was clearly an incentive for driving schools to pass folks, and so it wasn't the same quality. Their fail rates were much higher. So worked in one case, not in the other. Anyway, evaluation research evaluates programs. So there's also just sort of random topic from nowhere, ideographic versus nomothetic research approaches. So ideographic is like idiosyncrasy. That's kind of how you think of it, or at least I think of it, is you're studying a particular individual to learn about their behavior. So ideographic research is about individuals. It's going to make sense in a sec. So it's the unique aspects of those individuals that are studied. So, for example, you want to know why, a counselor, for example, wants to know why Bob is depressed. Not everyone, just Bob. So that would be an ideographic approach to doing research, and so their therapy is ideographic, trying to figure out why Bob's depressed. So in medicine, for example, it's patient by patient. They're trying to solve problems. I'm an epidemiologist, and in epidemiology, we're also trying to solve problems, but we do it at the population level. So medicine would be an ideographic approach, and epidemiology, you're about to find out, is what we call the nomothetic approach. I'm trying to solve problems across multiple people. So here we go. The nomothetic approach is when you study many people to learn general laws of human behavior in social phenomena. So we develop theories of why people in general are depressed, not just Bob, but people in general. And so, again, using the same comparison, it's epidemiology. It's a population-based approach to doing medicine. Literally came out of animal husbandry and herd management, where they're trying to keep the herd healthy. That's where the whole herd immunity sort of language comes from. Whereas medicine is, an individual level sort of endeavor. So moving on to the next random topic that's got to fit somewhere is laws, theories, and paradigms. So laws, what we're trying to figure out. These are the underlying systematic principles by which we think the universe operates. They figured out some of them in physics, for example, pretty well, because a lot of things are deterministic in physics and the hard sciences. So behavioral determinism, specifically determinism about behaviors, would say that people simply behave according to a large set of rules. Like, it's a really big set of rules, but you know what? We could find these underlying rules to why people behave under a deterministic approach to behavior. So your behavior, for example, like some of these folks it goes pretty crazy, like all the way back to the Big Bang caused everything. So the reason, your tire became flat a couple months ago was because the Big Bang. It all causally kind of goes back to that initial event, as opposed to free will. So under a free will model of behavior, we believe that people choose how to behave according to this large set of rules. So there's still rules that generally guide our behavior, but people choose how and whether and when to follow those rules. So there's a famous quote here by Pascal. People may be no more than reeds in the big scheme of things, but they are thinking reeds. So that would be a free will sort of view of things. So that's laws. Theories are our tentative statements of what we think laws are. So we use them to explain behaviors or phenomena. And good theories have 4 properties. They are efficient. So efficient just means they organize a lot of information succinctly, like positive reinforcement, the behavioral theory of that. It organizes all sorts of behavior of kids and of prisoners, and right. So animals. So it actually does organize a lot of information succinctly. So therefore, behaviorism, specifically positive reinforcement, is pretty darn efficient. They have intellectual value, meaning they stimulate or satisfy our intellectual curiosity. And they do actually offer insight into behavior. So you can use them to predict things, for example. So predictive value, obviously the next one. So we can use them because they're efficient and they have intellectual value. We can use them to make predictions about future behavior and therefore potentially change future behavior. They also have heuristic value. Maybe this is the 10-cent of word of the night. I thought the other one was pretty good, but parsimonious, but I don't know, heuristic is pretty good too. It's a fancy word that says, you know what, good theories motivate us to do more research with specific hypotheses. That's what good theories do. So they have heuristic value. So finally, we have paradigms. Paradigms are really broad models of how we view the world, like very broad models. So behaviorist approach to things, a psychoanalytic approach to things. There's cognitive approaches in psychology that we follow. All these are very broad sorts of views, ways to view the world. And they actually mostly go eclectic these days. Eclectic meaning several different paradigms, or use the paradigm that's most appropriate for a particular situation. But again, paradigms are just very broad models of how we view the world. So what are the two types of causality addressed in research? There is soft determinism. So soft determinism is what we don't usually think about. Determinism is just causality, sorry. This is when something happens and it affects the probability that a subsequent event will happen. It doesn't necessarily cause it every time, but sometimes it causes it. So we call that probabilistic causality. A sometimes, but not always, leads to B. That would be a soft deterministic approach, or probabilistic causality. So A sometimes, but not always, leads to B. So if A occurs, it increases or decreases, depending on the situation, the likelihood that B will follow. So what am I talking about? Well, for example, we know that children who are reared in abusive households are also more likely to become adult abusers. It doesn't mean they always become abusers. They're more likely to become abusers. If you understand the logic there, then you understand probabilistic causality. You're more likely, for example, if you come from a household with an alcoholic parent, to be an alcoholic yourself. So it doesn't mean you will. It's not the other type of causality we're going to talk about, but it does increase the probability, hence soft determinism specifically. So the other type of causality is what we call hard determinism, and that's when an event always leads to some subsequent event. So it's absolute causality where A always leads to B. So changes in A result in 100% predictable change in B every time. So we don't get a lot of these in psychology. They get these in the hard sciences where, you know, something happens, you kick the ball or you drop the ball and the ball falls, right? We don't get a lot of those. We deal mostly with soft determinism in psychology. So here's one though. Decapitation always leads to death. That is a hard deterministic thing, I guess, except in chicken. Well, not even in chickens. It just takes a while, right? So that would be an example of hard determinism. So other just random topic I got to hit is two types of reasoning in research. Let's talk about inductive first. So inductive reasoning is when we reason from specific instances to general principles. So it's going from observations to try to develop theories, right? So we develop theories from our observations. So for example, psychiatrists noticed that emergency room visits for depression are consistently higher during low barometric pressure and cloud cover, that is fall and winter, than under other atmospheric conditions. So they kept observing this. ED visits do go up. And so they developed the theory of seasonal affective disorder. So that is, people have seasonal sort of depression, for example. So we also do this in real life. We use inductive reasoning. So let's say you notice that your close friend who grew up in an alcoholic family consistently seems to end up in relationships with alcoholic partners. Object relations theory is what you're using. If you're making those connections from your observations, you're saying that, you know what, they understand how to relate to folks who are alcoholics, and so they tend to be drawn to such people. So deductive reasoning, on the other hand, I always think of it as down, D for down, is going from general principles, so up in the sky, to specific instances. That is deductive reasoning. So we use that to generate research hypotheses from theories. So deductive reasoning is used to generate specific research hypotheses for our studies from general theories. So what's a research hypothesis? Well, it's an explicit statement about the expected results for a specific study. Notice all the terms that are italics. So it's explicit about expected results and for a specific study. That's a research hypothesis. So for example, you're sitting bored in a waiting room and you predict that other people waiting who appear fidgety and restless are more likely to be there to get dental work done versus those who appear more relaxed. Maybe they're just driving, right? And so you based on this sort of theory, that is generalized anxiety theory, you come up with a specific hypothesis that the fidgety people are probably the people who are there to actually get work done. So back to your friends, you probably would guess if that friend had recently gotten divorced that he or she were going to end up with the same type of loser again, probably just like their parent, probably an alcoholic, right? That would be using deductive reasoning to make a specific hypothesis about what's to come. So that would be specifically, again, using object relations theory to develop a specific hypothesis about what's going to happen with your friend. So we deal with very complex constructs and variables in psychology. So what is a construct? It's a label for a domain of behaviors. That's what a construct is. So people are complex, and so studying them is not so shockingly also a complex thing to do. So again, soft determinism is how most folks act, and so we have these very complex things we study. So for example, there is attraction. So what is attraction? Like, how do we study something that's so complex like attraction? Well, we break it down analytically into its smaller component parts is the short answer. How about depression? So depression is a very complex construct or a complex variable. How do we measure that? Well, there's Beck depression inventory. We have folks who are diagnosed and not diagnosed, for example, different ways of breaking that down. Intelligence is another one. Intelligence, there's several, right? It's not just like you take the one thing, the one scale, and you get an intelligence. It's actually made up of lots of different subscales. The WISC, for example, there's like visual intelligence and vocabulary intelligence and spatial ability intelligence, and all those things are important parts of this larger construct. Neuroticism, one of the big five, is another complex variable. Conscientiousness is another one. Self-esteem, super common thing we talk about, but like, does it really exist, right? How do we know these constructs and complex variables really exist? They're not things you can touch. You can't touch someone's self-esteem, right? So how do we measure them if they do exist? So that's the next topic we're going on to. And the thing on the right is something I put together when I was a grad student at Sac State. I just got so tired of reading stories or studies where, oh, that was a Freudian slip, where in the journal article, instead of calling the thing they were talking about something specific and measurable, they were constructs. And these are some of the words that came up just from reading through there. They basically mean thingamajig. So how do we measure these constructs and complex variables? Through reductionism. That's the analytic approach of the scientific method. We reduce these constructs and complex variables into smaller, measurable components. That is, the scientific method is analytical. So intelligence is a complex construct, and we measure it by the 12 Wechsler subscales of the WAIS, right? Safe driving behaviors, I discussed earlier. How do we measure safe driving behavior? Well, when we tested folks, we looked at their vision, we test their knowledge, and then, if they were good on both those, we'd actually put them out in a car and give them a skill test. So an operational definition is a clear statement of how a variable was measured or defined in a study that's replicable, there's that word again, by others. So your operational definitions in a study are exactly how you measured or manipulated a thing. And so they have to be clear enough when you make them that other people could repeat what you did. That's the whole replicable. So short-term memory, for example, someone might operationally define in their study as recall of 3-letter words versus questions about some sort of passage they read. Like, those are two different different operational definitions of short-term memory. This is one of the reasons our studies vary so much in the results. Depression. So you could operationally define it as people who have the clinical diagnosis, or you could operationally define it in research by high scores on the Beck Depression Inventory, the BDI. So both of those are totally valid ways of operationalizing depression for study, but again, you might get different results because they operationalized it differently. Extroversion could be operationalized in a study as, those 1 to 7 I agree sorts of things. The extent to which you agree, we call those Likert scales. I like to socialize, 1 to 7. I enjoy speaking in public, 1 to 7. And higher scores on those things, added across multiple of them, suggests you are more extroverted. And friendliness. You could define or operationally define friendliness as the number of close friends a person has, and someone else might think of friendliness for their study as the amount of time they spend with friends, right? You might have a lot of close friends, but you'll never see them. So two different ways of operationally defining studies, or variables for studies. So in terms of getting started doing your research, you're all going to have a dissertation, is my understanding. There's a couple things I just want to throw out there that are important. Step number 1 of doing your research is to do a literature review. So you want to do a review of the relevant information that's already published out there, so you know what's sort of the next step, or what would be actually contributing to the literature. You got to know what the literature is. So usually the first or second chapter of your dissertation is a big old lit review of things. It varies by school. So there's these things called meta-analyses that I want to point out. They are very useful, and they used to have a bad rep. So meta-analysis is basically a mathematical literature review. So instead of allowing people to just kind of go through things willy-nilly and emphasize what they like or they think is more important, these are actual mathematical syntheses of findings where they put things together, and they are, in my opinion, particularly in your field and my field, one of the absolute best sources for getting what is the current state of affairs or the current best practices for things are found in meta-analyses. So there's the best source for summaries about current knowledge of a particular topic. So when you're doing your lit review, make sure to pay close attention to meta-analyses on your topical area. So what are the best practices, for example, for treating different types of psychological conditions? A great place to get information on how to treat a particular condition or how to treat particular offenders or whatever it be is to look for a meta-analysis that discusses that, because it's more likely to be unbiased. So other final topic that I just don't know where it fits is talking about pilot studies. So pilot studies are little studies that you do before you do your big study. So they're small scale studies that are used to test your procedures, or whether your measures work, how long it takes, etc., that you plan on using in some sort of bigger study. We call these pilot studies, and they don't have to be fancy. You could use your in-laws or whatever. It does not matter. So you want to get really basic information about your procedures and materials before you start using them widely, and you do not want to be that person who has to go back and recollect their dissertation data. You want to know, Do you understand the instructions? How to complete the questionnaires? Can you understand it because the reading level is right? Those sorts of things. You just test in a really small study. So do people who watch your video that's supposed to be manipulating whether there's a weapon scene in a crime scene or not, do they even notice the weapon? I mean, is it obvious enough? Are they paying attention enough? How long does it take to watch those videos? Are people going to drop out of your study because it takes too long? These are all things that you can study in a pilot study before you're collecting your actual data. So my bit of advice is to save yourself from absolute despair and pilot test your measures, instructions, and your procedures before you actually go live with your dissertation data collection. So a lot of folks show up at my door with nightmare stories because they failed to do this. So take my advice and actually do your pilot testing before you start collecting data.